So now let's talk one-to-one and onto. Definition. A function f is one-to-one / we also call it being injective if no element in B is related to multiple elements in A. This function is going from A to B, by the way. So if no element in B is related to multiple elements in A. So real simple. If we have A here, we have B here, and we have 1, 2, 3, A, B, C. This function right here, not one-to-one. It's not one-to-one because 1 maps to A and 2 maps to A. So this element here, this element A, is mapped to like 2 elements in our domain. So that's no good. And this is why we call it one-to-one, because a one-to-one function is where one element in the domain goes to one element in the codomain. That's how they're related, right? And so that's kind of like, this kind of gets the idea of like what like a one-to-one correspondence is between things. Like if there's a one-to-one correspondence in our group between our group and the friends group, that would mean that each of us map to exactly one friend, and all the friends are mapped to. Yeah. But anyway, so this is what one-to-one means. Now, this situation right here, where we have like that, this is onto. Or sorry, this is one-to-one. Since every element in B goes to exactly one element in A. Or sorry, every element in B goes to one or fewer elements in A. Because if we had a D here, this is still onto. Because B is related to just B can't be related to multiple elements in A, but it's fine if it's related to one or less. Any questions? Let's do an example real quick. Example. Let's do f from R to 0. So f to the positive or greater than or equal to 0 real numbers by f of x equals x to the 4th. Claim oh sorry, I want x cubed. Claim f is 1-to-1. So here's how you prove something's 1-to-1. We prove a function is 1-to-1 by setting 2 outputs, f of A and f of B equal, and proving then that A must equal B. So the way you prove two functions is 1-to-1 is it's kind of a contradiction-like thing, but not really. You're kind of going like, okay, let's assume there are elements A and B, such that f of A does equal f of B. And then you're proving that A must equal B which basically means that, well, if f of a equaled f of b, then we must have a equals b. So it can't be different. There can't be two different elements that map to the same thing in B. Therefore, f is 1 to 1. So assume there exists A and B in R. This should be R to R, I'm sorry. A and B in R such that f of A equals f of B. So A of B and R, we use R here because it's for the domain. So assuming there's just an A and B in the domain, so the f of A equals f of B. Thus, this means that A cubed must equal B cubed by substitution. Because that's what f equals. That's what f of A, f of B equal. Hence, A cubed minus B cubed must equal 0. Zero by subtraction. And that implies, if you guys remember factoring rules, that A minus B times A squared plus AB plus B squared equals 0. All right? So thus, by factoring, thus A minus B equals 0, or A squared plus AB plus B squared equals 0. All right. Now, I don't want to waste your time. I'll say we can prove that A squared plus AB plus B squared cannot equal 0. If we had time, we'd do it, but we don't have time. So we can't prove that A squared plus AB squared cannot equal 0. So thus, A minus B must equal 0, which implies A equals B. Therefore, F must be 1 to 1. The point is, we started here, assuming this, and we ended with this. So you start by assuming they have two things that go to the same element in B and prove they must be the same thing in the domain. So this proves that there can't be two things in the domain that map to the same element in B, same element in the codomain, because if they do map to the same thing, they must be the same thing. They must be equal. So they can't be two different elements, I should say. Any questions on this? All right. Now let's talk one on two. We say a function is onto / surjective is what we call this. A function, I'll say a function f from A to B, if every element in B is in the range of F. So we're saying that every element of B gets hit, i.e., for all Y and B, there exists an X and A such that F of X equals Y. So to prove a function's onto, we need to prove this right here. All right, and so to do that, let's say, let's do a, and this, by the way, is standard proof. It's a universal statement with existential statements. We have mixed quantifiers here, but we know how to do this kind of proof. Let's do an example of F from 0 to infinity going into the real numbers by Fx equals ln of x. Claim. F is onto. So notice a big thing here with functions. I was saying that our middle school definition looked at functions as things that did something. They only looked at the function of a function, but we like to look at functions as actual things themselves that have properties. That's why we say F here. Notice there is no F. We're not saying F of X. We're looking at F outside of its context to X. Right? We're looking at F outside of its context to any input. We're saying the function F itself, it's a thing that's onto. Interesting. Anyway, though, it's like when you start seeing your parents as independent people themselves. The point is F is onto. How do we prove this?